Last time, we learned some theories about the artificial neural networks. We learned how to code a single neuron with several inputs and calculate the output. We also learned about how to train a neural network. For that, we had used a training algorithm known as the delta rule. In that day, we did a small example and implemented all those details and theories in the MATLAB program. After that, I asked you to do a little bit of improvising to improve your program based on adding a bias and several layers and so forth. At the end of that day, we discussed about how to use the MATLAB toolbox to create a neural network and to train it. So what you are seeing here are the two commands that was used to create a neural network in MATLAB. Now the first one is the more modern syntax. The one below is a little bit older. So using these commands, you are able to create a neural network. Then we went ahead and did a little bit of training of the neural network and also simulating of the results. The experiment we did on that day was a very simple one. We had marks and pass-fail grades. So it's a very straightforward and simple kind of example. Today we are going to expand on the MATLAB toolbox, but try to do it for a real-world application. So today we are going to do a neural network to classify iris flowers. Now the iris flower dataset is a standard dataset, so you can find it in the internet. Let me guide you step by step on how to do it. Now when you're doing a neural network, first thing you need is to have a lot of data. More data you have, the better it is. But remember, this data also needs to be in good quality. As you learned in the previous lecture, if you don't have boundary cases, your neural network will not be able to classify the classes that well. So it depends on the quality and the quantity. Now let me share my browser window. So what I'm going to search is iris flower dataset. So I'd like you to follow the course, follow these steps along with me. So you can see there are several places where you can find the iris dataset. You have it in the Wikipedia. But what I like most is to catch it from this particular website. The reason is this university website has a lot more information and a lot of data sets related to artificial intelligence. So although the Wikipedia has the iris flower dataset, some of the data, it has very limited amount of data. Instead, I will go to this particular website, Machine Learning Repository, and at there, you will land on this particular page. Now it has certain details. It has an image of the iris flower and some summary. For example, this is a multivariate dataset. There are 150 samples. Instances means samples. And each sample has 4 characters. Right? Like that, you have a lot of data. Now, where is the actual data? Now, here you will have a data folder and the dataset description. Now, if you go to dataset description, it will show you some characteristics of this iris dataset. Now, let me just open it using the notepad. This is the data description. You can see the title, person who created it, and most importantly, we have these facts. There are 150 samples, and each sample contains following details. First attribute is the sepal length. Now flowers has sepals and the petals. So the first attribute is the sepal length in centimeters. Second one is sepal width, petal length, and petal width. The fifth one is the class of the flower. So there are three different types of flowers: Iris setosa, Iris versicolor, and Iris virginica. Now the fifth one will be one of them. It will give you what flower type this one actually belongs to. We have some statistical summary as well. So that is the basic details of our dataset. Now let's try to download the original data. Now in this site, this is a community site, so people have uploaded the data and they have done it in different formats. Some of the data will be in Excel format, in Excel files, some of them will be in the text files, some of them might be in zip files. So like that, they have different formats. So you may not be able to use the same importing method for all of them, but let's look at this one. When you go for Iris dataset, you can see there's actually a file called iris.data. Let me click it and it's downloaded. And if we open it using, let's say, Notepad, you will see something like this. This is known as a comma separated value pairs, or in other words, CSV. You can see there are values and they are separated by commas. You have first value 5.1, comma, second value 3.5, 1.4, 0.2, and after the comma, you have the last value, Iris setosa. We can basically understand these are the sepal length, sepal width, petal width, and the flower class. Now, before going further, I want everyone to download this dataset and have that particular folder open so you can work on further details. So please download the given data. You can find the web address and start downloading. Once you finish, let me know. So those who joined the chat recently, please go to this website. It's for download Iris data and download the Iris data file. Let me put it in the chat window so it will be easy for you to download it. Once you download the data file, there are different ways you can use that data. If you really need, you can use MATLAB for all the pre-processing and the training of the neural network. But sometimes it's easy to use a third-party tool like Excel to do some of the cleaning of the data. So it's up to you to decide what to do. For this one, I'm going to use Excel and show you the actual data and some of the steps you can do for the pre-processing of the data. So this is a new Excel sheet. And I'm going to drag and drop my data file into the Excel sheet. I'm going to drag and drop my data file into the Excel sheet. So it opens the SSV, it opens the CSV file, and you should get something like this. Everyone able to come up to this particular point? Or are you still having any issues? if you're having any problems, please let me know, because we are going to use this data set throughout this today's session. So if you didn't get it correct, if you didn't get it correct at the first time, try it again. Otherwise, you will be stuck at late of this session. If you finished downloading the data, please let me know in the chat window so I can continue the rest of the lecture. For those who came late, I will post the URL again to the chat window. Go there, download the data file, and drag and drop into the Excel. So you will have an Excel file with this kind of data. Now let us continue with reprocessing of the data. First thing we notice is all this data is in a single column. But we know from the data description, these should actually be separated into 4 different attributes: sepal length, sepal width, petal length, and petal width. So the Excel, there's an easy way to do this kind of conversion. If you go to the data tab, you will have this option, text to columns. So I click that one. Since these values are separated by commas, let me say comma. We will have this kind of preview, and we will press next and finish. So you should end up with 5 columns similar to this one. The first part is done. But you will also notice now our data has some text in it. We know the neural networks cannot process textual data. It should be a number. So I need to encode this into a number. And of course, if you go through this data, you will notice first part is iris setosa, second part is iris versicolor, and third part is iris vertical. For the simplicity, we will consider only the first two flower categories at the beginning. So I'm going to delete everything from 101 to below. In other words, I will remove the third category. Now I have only two flower types in my data set. I am going to replace all the Iris setosa by 0, and all of Iris versicolor by 1. Now all of my data is in numerical format. Let me know if you have come up to this particular point where you have 100 data and all of this data is in numerical format. When completed, please let me know in the chat window so we can continue. Okay. Now when you look at this particular Excel sheet, you will notice one thing. That is, they are in an ordered fashion. The first 50 belongs to one flower type, and the second 50 belong to the second flower type. But for neural network to work, it's better to have a randomized set of data. That means instead of having the same type of data continuously, we like to shuffle it. So how can we shuffle the data in this Excel sheet? You can do the shuffling inside the MATLAB, or we can use a small trick in Excel to rearrange the rows. So what I'm going to do is I'm going to add a new column to the beginning, and I'm going to create a random number in that column. Now the first column has a random number. Now this is purely only for randomizing the data, so it doesn't have any effect on the actual data. We are going to remove it later, but for the time being, we will be creating this random number. And now I'm going to select all the data and format it as a table. You can see it's formatted as table. Maybe you can just select up to this point as well. It's up to you. So what it had basically done is, by converting into a table, we make sure all the values moves together. So in a table, each row represents a record. So when you're doing any kind of row changes, all the values in the same row will move together. We create a random value at the beginning and we create a table. Now I am going to sort it by the random number. So I start with the smallest and set to the highest value. Since these numbers were created randomly, when you sorted it, the sorted values will again be converted to random. And you can see the first one belongs to category 0. Second one is 1, 1, 0, 0, 1, 1, 0, 0, 1, 0, 0. Like that, now you can see all the values or the samples have been shuffled or randomized. But remember, you have to convert this into a table. Otherwise, when you sort it, only the columns will be sorted by itself. You won't move the whole record. You can see only this particular column is sorted, others are not sorted. They have just moved up and down along with the connected random number. So we can see the data have not been changed, only their place or the location had been changed. Once you have done that, you can either cut, paste, remove this table and everything, or you can just select the original data. You can select the original values and paste it to different Excel sheets. It's up to you. If you want, you can cut and paste, or you can just remove them as well. So I'm just going to remove this column. Its function is completed. Only reason I put this random number is to shuffle the columns, shuffle the rows. So I don't need it. So I can remove it. Now I have the original data set. I can remove this heading as well. Oh, let's just keep it like that. So I can show you what happened when you import this into the MATLAB. Of course, you need to save it now. Let's save it to desktop. Now I save my file to the desktop. Again, a checkpoint. Let me know when you have come up to this point and have a data file saved in your desktop or some other folder. That data file should have only the numbers, and we have chosen only to use the first 100 samples, and the flower name had been replaced by a number. So once you had done all these things and made the shuffling of the rows, please save it to some place and let me know when you have finished doing that. Okay, hopefully now everyone has this data file in the folder, and you could try it by writing this particular small program. First you clean all the workspace and command line and everything. Then you load the data file using the load command. Please run it and know if it works. If it is working, let's okay, you can do that. So when you have loaded this data into MATLAB, then we have to do a little bit of pre-processing as well. For example, you can see now data is in a particular format. And the samples are in row wise. So this is the first flower, second flower, third flower, like that. Column wise, what we have is the attributes, length and width and flower type. But in MATLAB, you need to convert into a different format before you can use the standard neural network toolbox. Your samples needs to be in the column-wise manner, and rows should have the attributes. So that means you have to rotate this particular matrix by 90 degrees. So to do that kind of thing, we can use the transpose function. So I can say data is equal to data iris transpose. Now you don't have to do this transpose for all the data. We have to do it for this particular set of data because it was in the different format. But you might find certain data sets that are already in the correct format. Then you don't do the transpose. So once you have done transpose, you should find all the attributes in row-wise manner and all the samples in column-wise manner, like this. So first flower, second flower, third flower, like that. So if your sample data is already in this format, don't do the transpose. You can use it as it is. Now we have made this transpose and now it is in the correct format. Now let us try to separate this data into two different categories. We need to separate them as training data set and the testing data set. The reason is we want to know how good our neural network is. Therefore, after training the neural network, we are going to give a test to that neural network and see how good it performed for that particular test. Now you can't use the same data set for both training and testing. It's just like when you want to test a student if they had learned something. Yeah? In the class, you can give him some sample questions, let's say 5 questions. So teacher can ask, go through these sample 5 questions and learn how it is done. Learn how to do this calculation or something. But to test whether that student had actually learned the concept, teacher would have to give a different question. It has to be in the same format, but a different question. If the teacher gave one of the questions in the examples, the student might just memorize the question and write the answer from the memory without understanding the concept. There is the same scenario happening with the neural networks. If you want to know whether the neural network has learned something, generalize the concept, you have to give it a different question to see how it performs. Therefore, at the beginning, we will separate our data into training set and the testing set. Training set is like the examples we showed to the student, so it can learn the concept. Same way, training data set, we will give full access to the neural network and ask it to learn by itself. We will use that data set for the training. Testing data set, on the other hand, we will not show it to the neural network. After the training is completed, we will give it only the inputs. So the neural network would have to predict the output. And then we will compare this output with the actual output we have. So if it had trained properly, it would get most of the answers correct. So that is the concept of separating training and testing data set. So usually you have about 75 or 80% for the training and 25 or 20% for the testing. So let's say train data set size. So we have 150, we will use about 120 for the training. And remaining 30 will be for the testing purposes. So I can say train data set is data. Now remember, we need to select 120 from here. So we need to select all the rows, but column wise 1 to train data set. Sorry, train data size. And then we can create the testing data set as well. For here, we will get the last set of data. What we had basically done is same command, but now we are starting from training dataset plus 1. That means 121 to the last one. NP is the last one. Sorry, yes, you are correct. 150 is for the original dataset, where you had 3 flower types, but we had removed the third flower type. So you have only 100 data, so you can't have a training data size of 120. Let's go by 80. So 80 you should be able to do. So 1 to 80 for the training, 81 to 100 will be for the testing. Now when you run the command in the workspace, you should see something like this. So for the training, you have this kind of training data set, and for the testing, you have the remaining 20. Okay. Now we'll move another step. Now we have a training data set, and that data set consists of set of data like this one. So you can see the first 4 rows are the inputs, and the last one is the flower type, which should be the output, or the one that we are trying to predict. So we need to separate the inputs and the targets. Targets means the output. We need to do it for both the training data set and the testing data set. We could have done it in a single step while we are doing this one, but for the clarification purposes, I have divided into two separate steps. If you feel like it, you can do it in a single line. Now I want to have the training input. So for this one, I take the training data set. In this training data set, rows from 1 to 4 are the inputs. That means petal width, petal length, and sepal length and sepal width. These are the inputs we give into the neural network. So from 1 to 4 rows are the inputs, and we are going to select all the columns. So for all the training data set of 100 samples, we are going to separate first 4 rows as inputs and the last row as the target. We'll call it as the train target. Last row or the fifth row is the output, so this would be train target. Now if you had two outputs, you have to use the two rows which are the outputs. If you have more than 4 inputs, then you have to match these according to that. So the idea is you need to separate the network input and our network target output. In this case, we give some attributes of the flower and try to classify the flower type. The flower type is on the 5th row, so that's why you put 5. And the attributes are in the 1 to 4, so that's why you put 1 to 4 in the inputs. And if you run this particular one, you will notice
So this should be training data set, no? Not test.
yes, it's my mistake. These issues can happen. So when you have found something like that, go to the error and you should be able to identify what's wrong with your one. Right. Now, if you look at the workspace, you have now training input 4/80. Which is like this. So these are the attributes of different flowers. You can see different flowers like this. And you also have training target. So for this input, network should predict 1. Or at least it try to learn like that pattern. So for this one, 4th input, our target is to have output of 1. So likewise, we have separated the training input and the training target. We can do the same for the testing. So it makes much sense to do it in the same line. But we will be using it only later. We will be separating the testing inputs and the testing targets. Again, all these 4 lines could have been done, could have been incorporated into this single line. Instead of saying 1 to, instead of saying all, you could have simply say 1 to 4. But I broke into 2 different sections, so it will be easy for you to understand. Now, when you run it, you should have few more variables. You have training input, training target, testing input, and what's the test input? Okay, you have the test input and the test target. Now we have done most of the part related to the coding. But we haven't still touched anything in the neural network. This is only the pre-processing. We just took some raw data and converted it into a format so our neural network can use. Now it's time to create our neural network. Can anyone remember the command to create a neural network? What is the command? Where's the command? What should I type here? Can you remember? You have a syntax called feed-forward net. So this allows you to create a feed-forward network, and in the bracket you can put the number of neurons in the hidden layers. Let's have a single layer. 3, just for the fun of it. You can change these values and try different values. They will give different performances. Now when you run it, you don't need it anymore. What happened to the command line? So when you run it in the workspace, you should see a new object called my_ANN. So now we have created a neural network and our data is already there. So let's try to train it. To train it, you can say train followed by the network name, followed by the inputs. So this would be the training inputs, followed by the training target. So with that command, we are ready to train our neural network. So let's run it and see what's going to happen. So the pop-up box is there. It's training the neural network. And this is the result. So it had trained the neural network. And I can get a performance graph as well by clicking this one. This is what the performance graph looks like. So I want everyone to work their code up to this point. And let me know when you have come up to this point. We can continue this particular course and see how we can simulate this particular neural network. But at the moment, I want everyone to come up to this particular point. So everyone is in the same step. Otherwise, if you lose in somewhere in this coding part, it will be quite hard to catch it up. So I can't personally come to you and advise you. So either you have to ask a question saying which part you missed, or you have to use the chances like this to catch it up, right? So try to see if you can come up to this particular point. So if you have done everything properly, you should be able to run this code, and you should be able to get a training dialog where the neural network is trained for the given data. Okay, so I'll give you a few minutes for those who have not come up to this point. So try to catch it up quickly. Right, now let's try to simulate this network and observe what kind of result it will produce. To simulate a network, the command we are going to use is the sim command. You can say sim, and after that you can give the network name, and after that you can give the input, whatever the input you like. So you can do it for one input at a time, or you can input a whole matrix of inputs and see the output for each of them. So let's try to input maybe a single one. So which one should I use? Now remember, when you are doing the testing or simulating, you have to use the same format. Let me be a little bit lazy and use one from the testing inputs. Let's look at this one. 6.2, 2.9, 4.3, and 1.3. 4.3 and 1.3. These need to be in the row matrix, right? So it should be the rows. You don't have to manually type it. I'm just doing it so it's easy to try a single one. 6.2, 2.9, 4.3, and 1.3. Right, the values are there. And what should be my expected output? Now, if you look at the second one, it should be a 1. Let's see if it works. So run this one. Okay, it predicts as 1. Seems to be working. But of course, you can't be sure for a single one. So it's better to try it for all the cases. So instead of saying input like this, I can say test target. Sorry, test inputs. And I like to save the prediction to another variable. Let's say ANN predictions. Okay, I run it and I can see there are several predictions. You get 0, 1, 1, 1, 0, and like that. If you are wondering why there's a minus sign in front of the 0, that is because this is not exactly 0, it is a very small number. So when you round it up to this 4 decimal points, it can be only shown as 0. But in reality, it's a very small negative number. You can see the actual value by going to this variable and double clicking on it one. So, this one. You can see the first one is minus 3.6 into the 10 to the power minus 9. So that's why you have minus sign here, because it's a negative number. But it's so small, it's almost like 0. So if you're done properly, when you run it, you should get an output like this. Now I need to know how good my network has performed. That means how many times it had correctly predicted the flower type. Now how can I do it? Now I have the output from the neural network predictions, and I have the output of the actual flower type. So I can do a comparison. If they predict the same flower type, that means neural network gets 1 point. If the predicted value and the actual values are different, that means it had failed to correctly identify the flower type. So I need to do a comparison between the neural network prediction and the actual flower type. But you have to be careful, you can't do a direct comparison. Why? You may have seen this first, let's take this first one. It says minus 0, 0, 0. Unfortunately, this is not actual 0, this is 0, 0, 0. After 10 zeros, you get a 3. So this is not 0, although it is very close to 0. And the real flower type is marked by exact 0. It's a 0. So if you just ask MATLAB to compare whether this value and the 0 are equal, MATLAB will say no. Why? Although this is very close to 0, this is not 0. It's a very, very small negative number. So MATLAB doesn't know what we want to do. It will do some numerical comparison. And mathematically, 0 and 0.0009 are two different things. So although the neural network seems to be predicting this one correctly, we can't do direct comparison. We have to convert these kind of numbers or round it back into our main categories. That is part of the post-processing. So how can we do that? We know this is 0 and we know the second flower type was 1. So anything close to 0 should be considered as category 0. Anything close to 1, for example, although this one says 1, the actual value might be slightly different. Okay, 1 seems to be predicted correctly. Sometimes you might get 1, 0, 0, 0 something. So although it might be displayed as 1, it's better to round it up to that particular class or particular integer. So to do that, we can do, so what is the best place to cut off these two classes? Now one category is 0, one category is 1. So anything below 0.5, it's better to be rounded down to 0 category. Anything above 0.5, it's better to be considered as category 1. So we can do a very simple comparison like this. In MATLAB, if you do a comparison like this, if that condition is true, it will be output as 1. If the condition is false, it will be output as 0. So this is a shorthand notation. If you want, you can write a small for loop to go through all the predictions and compare it with 0.5. Inside the for loop, you can use the if condition to map them to either 0 or to 1. But this is a easier way to do it, so that's why I'm doing it. So if you have, let me show you an example how this works. If I said 1 is larger than 2, output becomes 0 because it's a false. 2 is larger than 0, that's a true, that becomes 1. So what I'm basically saying is, I want to compare this value against 0.5. If this value is larger than 0.5, my output would be 1 because it's a true condition. If this value is less than 0.5, my output will be false. So that means my output will be 0. So anything above 0.5 will be automatically be converted to 1. Anything below 0.5 will be converted automatically to 0. The good point about MATLAB is it will do this for all the elements in a matrix. You don't have to write a for loop. So when I run this code, it will do this for all the elements in the given array. Now you can see it doesn't have any minus zeros or anything because this is exactly 0 or 1. Now this I can compare with our original prediction. So let me say predicted class. And now I can compare. So how can I compare? I can do something like this. Equals. What is my actual output? Actual output means the real type of the flower. By going to the field and looking at the flower, the real flower type will be given at by testing dataset. Let me check why it is saying it's not equal. Any predicted class has 1 to the 20. And the one I'm trying to do is testing dataset. Sorry, this should not be testing dataset. This should be testing target. I want to compare to the target, not the whole dataset, only the target. And this is small spelling mistake. This should be class, not this one. And now if we do it, this test target. Right, now it's done. So what is happening basically is neural network is looking at the testing inputs. So we only feed it the flower length and width and all these things. So it look at this data and predict a value. Now that value is not in the original classes. It can be anything in between. It can be a 0 or it can be 1 or anything in between. But in our original labeling, we had converted one flower type into 0 and other flower type into 1. So our predicted values also need to be converted back into that original format. Otherwise, we can't compare. So in this particular line, we are comparing it against the midpoint, 0.5. So we can sort of round it up or down to match a given class. So when the neural network says 0.1, we can assume it's actually trying to predict the class 0. But since you are working with real weights and things like that, it may not get exactly 0. You might have some deviation. So this rounding up is for removing that deviation. So this ANN predict class will basically have zeros or ones. Then I'm using this comparison operator to compare those zeros and ones with the actual target. Actual target in the sense, the correct answer. So this ANN predict class is like the answer written by the student, and the test target is like the correct answer in the marking scheme. So you need to compare them. So you are doing a comparison. Again, this is a logical operator. So if they are equal, you will get a 1. If they are not equal, you will get a 0. You can do it for a multidimensional array as well, multidimensional matrix. In that case, each of the elements will be compared against the respective element of the other matrix. So you have 20 elements in the first one, 20 elements in the second one. The first one will be compared against the first one. Second one of here will be compared against the second one. Like that, all 20 will be compared. So you can see the result. It seems like everything is correctly predicted. If I want to get just the result, I can do a simple summation. If everything correctly predicted will have a value 1, everything not correctly predicted will have a value of 0. So basically adding them will give you how many times it was able to predict correctly. Because 0 will not increase the value of these summations. Right? So when you run this one, I had asked you to classify 20 flowers, and you can see all the 20 flowers have been correctly classified. Okay. Again, I will give you a few minutes for those who have not catch up to this place to try this simulation part and to test the results. Once you finish, please let me know in the chat window. Is it okay? It's raining out here, so I hope you can hear my voice. Anyone is still trying to figure out what had happened? So it's similar to what we had done in the previous day. Only thing is, instead of using some data like marks and class, we had used some real data taken from a data file. But rest of the things are in the same way. We have the feed-forward creation command, training, simulation, and finally comparing the results with the actual data. Now, when you're using this kind of syntax, you might notice it becomes a little bit hard to test the performance of the network, because every time you try to run the code like this, it will go from the beginning. It will import the data, then train the network, and then only it will go for the testing. So this can become a headache if you have a very large data set and you don't want to train the data set every time. In reality, you don't want to train the neural network every time. Once it is trained, you should be able to reuse it without training it again and again. So there's an easy fix for this one. What you can do is you can save your neural network into a file and have the predicting part or the simulation part in a different script file. So if you want, you can run only the simulation part. So that's what I'm going to do. If I want, I can save only the part of the neural network, only the neural network variable. But if you put it like this, it will save all the variables in the workspace. So I'm going to follow that one. This one. So when I run it, it will train the neural network, and a new file will be created in the current folder called engine data. Now I'm going to get a new script. And here I'm going to load the data back into the from this file. So you can see now if I want to test something, I can simply run this particular step. It doesn't have the neural network training component, it simply loads the data from the previous data file. Now the data file has data of already trained neural network. So when I run this one, I can simply do the testing. If I want to train the neural network, I can go back to the training file and make any changes here and run it. So once it has finished running, it will automatically save them into this given data file. So using this data file, you are able to effectively save some time. Is it clear to you all? Shall we move to the last section of today's plan? If you have any questions regarding this one, please let me know. Okay, it seems like no one has questions. So we shall be moving into the last part of this iris data prediction. So if you remember, at the very beginning, we did a small modification. We removed one of the classes from our dataset. So we can train our neural network to identify two different classes, not three. So with that, we have simplified certain amount of programming. Now we shall move back to the original dataset, which has all the three classes and 150 samples, and see if the neural network is able to predict all the three classes correctly. So to do that, let's go back to our Excel sheet. This one is already removed some of the data, so let me take a new Excel sheet. We have drag and drop iris data. This one is still having 100 data, so I might need to download it from the website. Okay, it's there. Now we have the data. We'll convert this single column into comma separate multiple columns. We will use the comma as the delimiter. Now they are basically converted. Now I have a question. In the earlier case, we had only two flower types, so we could get away with 0 and 1. But now we have three flower types. We have Iris setosa, Iris versicolor, and Iris virginica. So what's the best way to convert these three categories into numbers? Because you know the neural network can't use textual data, it should be converted into numbers. So I must find a way to convert this text for the flower categories into numbers. So can anyone suggest a way to convert the three flower types? What should I use for the first one? People at the chat, can you hear me? It's 0, 0, 0, 1, 0, 0, 0, 0, 1, and I think second one is 1. Okay. Next one is addition. We don't have to stick to binary. All the binary is okay. Neural network doesn't need to be in the binary. What about using 0, 1, and 2 as the 3 flower categories. Is it a good idea or is it a bad idea? So 0 for the first flower type, 1 for the second flower type, and 2 for the third flower type. So if you want 1, 2, 3 as the flower types. What do you think? Is it a good idea or are there any drawbacks in that particular concept? Let me tell you why it is a bad idea. Yeah. Now, neural network is not a one large computing machine. It's basically uses small processors to get to the final result. Okay. So each one has a small effect on the outcome. And what you see as the output is the total net result of those small impacts. So if you have two neurons trying to decide them into opposite ways, you might get them completely different result. Let's give you an example. Let's say you want to predict who's going to win the next World Cup. When is the next World Cup scheduled? I'm not a big cricket fan, so you have to tell. When is the next Cricket World Cup? That's not a neural network question. That's a common sense question. Since I'm not into cricket, I'm asking you guys. Hopefully, people here know a little bit about Cricket World Cup. So when is the next one scheduled? 2020. Okay, thank you, Cameron. Who do you think are the top two teams that's going to come to the finals? Anyone can propose. Who will be the top two teams? Maybe Sri Lanka or something else? Australia, West Indies? I don't know. Whom do you think is going to come to the final? Best two teams. It should not be this bad to India and England. Okay, I don't know whether they are the best teams. Okay, maybe in the modern day that might be the case, right? India and England. So let's say I want to simulate something like a neural network to predict who is going to win. Okay. So we'll assume all the 18 people in the chat are the neurons. So they get to vote who's going to win. India is 0, England is 1. So we can ask people to vote either 0 or 1. And if I get a lot of zeros, I would say, okay, now India is going to win. So if I'm going to bet something, I would say, okay, I will bet on India. If I get a lot of ones, that means most of you cricket experts think England is going to win. So I'm going to bet on England. Right? So that's one way of doing it. You can vote there. But rather than counting each and every people, what I can do is I can add all the numbers together and take the average. Okay. If everyone in the class said India is going to win, my average will be 0. If everyone in the class said England is going to win, there will be 21s. So divided by 20, my average will be 1. If half of the people said India and half of the people say England, what would be my average value when I did the mathematical part? What would be the value? Simple maths. Half people India, half people England. What would be the average value? It would be 0.5, right? 0 will not be counted, so half people who voted for England will not be added back, and 1 will be 10 students will vote for 1, so there will be 10. So 10 divided by 20, you get 0.5. So if I get 0.5, I know it's not good to bet because people lie in the middle. Half of the people think India is going to win, half of the people think England is going to win. If I get something like 0.9, which class should I put my money on? What do you think is the class that is going to win? 0.9? So what's happening to people in the chat? Are they feel half asleep? I can't see many people, only few people are answering. If I get 0.9, what should that happen? We went with England. So when it gets close to 1, that means it's more confident England is going to win. And when it goes close to 0, that means it's more confident India is going to win. Okay. Now that's worked quite well for 2 classes or 2 countries. Let's add a third one. What country do you want to add as the third country? Give me a name. Another country to add. It's a World Cup, so you will have multiple countries. Anything you prefer other than India and England? Australia, okay. Give me a bad country. Australia is a good one. What is the worst country now you have in these days? Very bad country, I want. Sri Lanka. Okay. Let's, I don't know whether Sri Lanka is that bad. Somebody said Bermuda. Okay. Bermuda probably is worse than Sri Lanka, right? So let's say 3 countries are now in the game. India, England, and the Bermuda. And I use the same method. Now I assign 0 for the India, 1 for the Bermuda, 2 for the England. Now, if all the people voted for India, what would be my average? Everyone vote for the 0. Everyone vote for the India. It would be 0. Everyone vote for the England. So that means everyone is voting for the number 2. What would be the average? 2. Right. Now here's the funny part. Now let's say half of the class decided to vote for India, half of the class decided to vote for the England. Then what would be the average value I would get? Half vote 0, half vote 2. Then what would be the average? You get 1. But now you have a question. Why? You had assumed number 1, you encoded number 1 for the Bermuda. So if you just go by the average and do it blindly, you might think, okay, everyone in the class thinks Bermuda is going to win. But that's not the case, right? None of the people in the class thinks Bermuda is going to win, but average happens to be like that. Similarly, if you put 0, 1, and 2 for the flower types, half of the neuron might be pressing for the 1 flower type, first flower type, half might be pressing for the second flower type, but because of that conflict, you might get the third flower as the most possible answer. So it's a misrepresentation of information, right? So we can't have that kind of thing when you have more than 2 flower types. Otherwise, you might get all these kind of nonsense things because you have 2 different extremes. Right? So to avoid that, we decide a different kind of voting system. Right? So instead of asking to vote for 0, 1, or 2, now I'm going to ask each student to have a small table. If they think India is the most winnable country, put a cross in the first box. If Bermuda is the most winnable country, put a cross in the second one. If England is the most winnable country, they think, put a cross in the third one. Then I do the same thing. I collect all your votes and average them. Now what I get is three different numbers. Right? So the average in the first one will give me how many percentage of you people will be thinking India is the best one. Second box, average of the second box values will give me the Bermuda percentage, and the last one will give me the England percentage. Now it gives me much more details. If I get something like 0.6, 0.2, and 0.2, that means more than half of the people think India is going to win. And about 25% of the people think Bermuda is going to win, and another about 25% people going to think England is going to win. So by looking at the average of these three boxes, now I am able to say which one is the most favorite country. Rather than averaging three numbers, now I have put three boxes. Each box has a 0 or 1, or you can put a cross in one of the boxes to denote which one you feel like winning. So that way you don't have that confusion. If you have 5 countries, that's fine. It's like in the voting system, you have 5 boxes. You can cross the which one you like. I finally added all the votes together. In the sense, when I mean adding, you add the first box of the first student to the first box of the second student, like that. So box wise, you have the averages. So you get the result. So you know which one has the highest chance. So the same thing applies for the neural network. So when you have 3 flower types, rather than putting it like this, you can have something like this: 0, 0, 1. And for the second flower type, somewhere below, you can have 0, 1, and 0. So what's basically happening is I am modifying my neural network so it will have multiple outputs. In this case, I will have 3 outputs. So this could be the 3 classes: 0, 1, and 0, and 1, 0, and 0. So my neural network will have 3 outputs, one for each of these output categories. So let's say I get something like this. Output of the first neuron is 0.5, second one is 0.9, third one is 0.2. So let's label them as class A, class B, and class C. What do you think is this neural network predicting by this particular output? Which class? A, B, or C? It's class B, because 0.9 is the highest one, so it seems like it's predicting class B. But it's not very confident, because a little bit behind it you have something like this one as well. So it might be class C. There is a slight chance of being class C, but it has a very high chance of being class B. If I had something like this, it's most likely, definitely it should be a class B, because all other 2 categories seems to be lagging far behind. It's almost close to 0. And you might get something like this as well. Now in this case, if we had to make a choice, it's better to go for the class B, but we should not be confident about this result. As you can see, it's not even half. So most suitable one would be class B, but it's not guaranteed. Most likely there's some error in the data, or there's another class that is coming up, or something went wrong with the training, something like that, right? So this is not a very confident one, but if we had to make a choice, it would be class B. But if I had something like this, now this would make a strong case for the class A. So we follow the same procedure for this one. This iris setosa. Now you have 3 outputs, and you would, from 1 to 50, you have this one, and 50 to 100 you have this one, and from 100 to 150 okay, for some reason it's not getting time. 400 and 250 you have this one. So for the remaining part, is the same as the previous thing. You remove this one, you randomize the data, import into MATLAB, and create a neural network. And once you train it, you do the simulation. Now, when you do the simulation, instead of one single output, you will have 3 different outputs, like the ones you measured here. You get 4 inputs, neural network output 3 outputs, 3 values. So by looking at them, you can decide what class it is. So easiest way to do this is to use the max command. There's a min and max command to find which one has the highest index, highest value, index of the highest value. You can use that to create the class, right? So I will leave that as homework for you. You already have the data set. You already know how to do it in the 2-class scenario. Now I have expanded to 3-class scenario. So try to do it as homework, and if possible, I try to create an assignment box so you can upload the answers there as well. So that way you can get some extra marks and get some experience, right? Any questions regarding today's lecture? It's almost 3:30. So any questions? Somebody asked whether I'm recording and upload it in somewhere in the previous hour or something. Yes, I'm recording, and probably I will upload it today or tomorrow. If you don't have any questions, we wind up today's session. So we will meet next day on another session. Please go through the lecture notes as well as try to do the given exercise. Okay. Have a nice day. Shall I close the window? Are there any questions? Yes, there are no questions. Okay. Then have a nice weekend.